So in the real world, when you start working with applications of mathematics, you will often find that you have to be able to work in rectangular form and polar form, and you should be able to work back and forth pretty easily. So that's what this lesson is about. The good news is there's nothing new except for applying what we already know. So our first example, we want to graph in polar form, we're going to graph in rectangular form, and then we're going to convert to polar form and show that you get the exact same graph. So x plus 2 squared plus y squared equals 4. So if I have to graph this, I'm going to rewrite it. I have x plus 2, which I'm perfectly happy with, squared, plus y plus 0 squared equals 2 squared. And I've rewritten it just so that I can easily find the center of my circle, which is at -2 and 0, which would be here, and has a radius of 2. So that takes me back to the pole on the right-hand side, or I guess to the origin because I'm in rectangular coordinates, and then to 4 on the left-hand side, and then I sketch the circle. And I'll do my level best to make a nice-ish circle. Ooh, that one's not bad. Okay, it's not good either, but it's not bad. Okay, so now we want to convert this to polar equations. And polar means that instead of having x's and y's, I'm going to have r's and thetas. And so I have tools in my toolbox I can use. First thing is I know that x and y are expressions of r sine and r cosine theta. So let's just go ahead and write that out. So x is r cos theta plus 2 squared plus y is r sine theta squared, and the whole thing equals 4. Now, I'm going to resist the urge. I've already determined that the radius equals 2, and so I kind of want to plug a 2 in for my r's, but that's not going to help because I want my final equation to be r equals something. And so if I fill in a 2 for my r's, I don't have any r's for the final equation. So I'm just going to have to do the algebra on it. First, I'm going to square this first binomial, and I get r squared cos squared theta plus 2 times 2 is 4 r cos theta plus 2 squared is 4 plus r squared sine squared theta equals 4. Well, I noticed that I have a sine squared and a cosine squared. I'm always excited when that happens because it could become a 1 easily. And it turns out that each of them have an r squared. So I can factor an r squared out and be left with r squared times cos squared theta plus sine squared theta. So when I combine them, I get this. That's 1. I'm done with it. And then this 4r cos theta, I'm going to subtract to the other side. Negative 4r cos theta. And then 4 on this side, if I subtract it to the other side, just is 0. And so I'm done with this step. Now I'm left with r squared equals negative 4r cos theta. Now I only have to divide through by this r, and I get r equals negative 4 cos theta. And that's exactly what you expect. We expect a cosine, meaning a circle on the horizontal axis with a diameter of 4. Negative says it's on the left-hand side of the pole. Done. It's exactly right. All right, let's do another one. Hopefully they're all that easy, or at least all that straightforward, if not easy. So now we want to graph 2xy equals 4. We'll graph in rectangular and then convert to polar. So to graph in rectangular, we solve for y and simplify. And we recognize this as a parent rational function. So the horizontal and the vertical axis, well, the horizontal and the vertical axis are both asymptotes, and the graph itself Looks like that. So now let's make our conversion to the polar form. So easily enough, I can see that 2 times, well, x, we're going to convert that to r sine theta. Excuse me, that's not correct. 2 times r cosine theta times r sine theta equals 4. I can do a couple of things here. One is I can simplify by reducing both sides by 2, and I can combine the r's into an r squared cos theta sine theta equals 2. And I'm beginning to see that I might have wished I hadn't done that cancellation, but that's okay. I can just multiply a 2 back in. So I'm going to divide by cos theta sine theta. So I have r squared equals 2 over cos theta sine theta. And here's the reason for suspecting that I shouldn't have done this cancellation. I can't really do anything with this. I could move cosine and sine up into the numerator, and then I would have r squared equals 2 secant theta cosecant theta, but I don't have any idea what to do with that. But I can multiply a 2 into the denominator, which would give me 2 cos theta sine theta, which is a double angle identity for sine theta, or sine of 2 theta, excuse me. And that's totally legal as long as I also do it in the numerator. So 2 times 2 is 4. And simplify the whole thing, or rewrite the whole thing. R squared equals 4 times cosecant of theta. And I'd like to have this r not be r squared. I'd like it to be just an r to the first power, but there's nothing I can do. There's no r on this side I can cancel with. I could take the square root of both sides, but then that would just be crazy. I wouldn't want something like that. So this is my equation for my polar form, or my polar equation for the graph that I've graphed in rectangular form. So that's converting from rectangular to polar. Let's look at some in the opposite direction. Let's take the polar equation, theta equals pi over 4, graph it in polar form, and then convert it to rectangular form. The graph couldn't be any easier. It's the line for the angle, pi over 4, and it extends across both sides. So now we want to convert this to rectangular form. We have a theta, we don't have an r, but we do have a theta. We want to convert to x's and y's. The best way to get x's and y's out of a function, out of an angle, is to use the tangent function. Tangent theta in this case is 1, because the tangent of pi over 4 equals 1. Tangent itself as a function is y over x, opposite over adjacent. And if that equals 1, then I can solve for y and I get y equals x. And that's clearly the same line as theta equals pi over 4. Super easy. The hint here, or the trick, and by trick, I'm using air quotes because it's not a trick, it's actual mathematics. But when all you have to work with is a theta, then use the tangent function to get your x and y's. So another trick, and again, air quotes for trick, is when you only have an r. So if you're given something in the form of r equals 5, well, graphing r equals 5 is a piece of cake. It's just the radius is 5 everywhere. So 1, 2, 3, 4, 5. It's a circle with a center at the origin. But we want to convert this to rectangular coordinates. When you're only given r, the trick or the hint is to use r squared equals x squared plus y squared. So you can convert r's to x's and y's if you have an r squared. I don't have an r squared, but that's easy to fix. R squared equals 25. So I can say x squared plus y squared equals 25. 5, and I'm done. This is the rectangular form of a circle with a center at the origin and a radius of 5. Last but not least, and perhaps more confusing, is another example with another trick, air quotes trick, r equals 2 sine theta. So if we graph this in this form, sine theta tells us that we're dealing with a circle on the on the vertical axis, and 2 says that I have a diameter of 2, which means a radius of 1. So if I call this 1, then the diameter of 2 gives me a circle right here. Positive 2 means the circle is above the pole. Negative 2 would mean below the pole. The diameter is 2 because of the 2, and it's a circle on the vertical axis because it's a sine function. Now let's go ahead and convert this one to rectangular. Now, we have a natural instinct to want to square both sides, so I get an r squared. But if I do that, I'm going to end up with 4 sine squared of theta. We don't really want a 4 sine squared of theta. We're not really sure what to do with that. So we're going to use a different trick that means it's just as simple as squaring both sides, but I'm just going to multiply both sides by r. So I get r squared, because r times r, obviously, r squared, and 2r sine theta. So when I multiply both sides by r, I get something else I can work with. Not only can I get my x's and y's, x squared plus y squared equals 2 times r sine theta is y. Unfortunately, this doesn't get me very close to something familiar for graphing a circle. So I'm going to subtract 2y from both sides. X squared plus y squared minus 2y equals 0. Okay? Still doesn't look very good to me, but little trick. I'm going to complete the square there. So I'm going to have x squared plus no coefficient to factor out, y squared minus 2y, plus I'm going to add some perfect square term, or a term that'll make a perfect square on this side, which is legal as long as I do it to the other side too. 0 plus the same thing. Let's make my new term. It's the opposite of b. No, it's b over 2 squared. And so negative 2 over 2 squared, negative 1 squared all the way to 1. So my formula, my plug in my b value, simplify inside, simplify outside. And that's just easier when you're working if you use that 2 different patterns. So negative 1 squared goes inside, but the 1 squared goes on this side. They equal the same amount. It's just easier to work with if you insert them this way. And so now x squared plus, we created a perfect square, so we can just write it as a perfect square, and 1. Now I have this amazing thing going on, which is I have x plus 0 squared plus y minus 1 squared equals 1 squared. I have a circle with its center at 0, positive 1, right there. X is 0, y is positive 1, and it has a radius of 1. Definitely a radius of 1.